Good day to all. Today we can discuss about aggregating numeric data in the subject foundations of data science. So, what are the ways in which we are going to statistically aggregate the data and summarize the numerical data sets? So, the three most important pillars which are used for aggregating numeric data are the measures of location, measures of dispersion, skewness. So, what is measures of location represents where is the center of my data? What is measures of dispersion represents how spread out is my data? Skewness represents is my data symmetric or asymmetric? So, these three categories together provide a complete statistical profile of any numerical values and guide decisions about which analytical methods and measures are appropriate. So first is measures of location. So where is the center of my data? That's the question, right? So they pinpoint a representative typical value around which the data is distributed. So the three things are mean, median, as well as quantiles. So what is this mean represents? As you know, it is the average of all the values. So for example, with the Python syntax, np.mean of heights, as we had discussed in the previous video 160.14 heights of some women's. So it is sum divided by n. So it is sensitive to outliers. One extreme value pulls it strongly. So for example, for the given 5 set of data, the mean value is the total value, the summed value is 835 divided by 5. So it is around equal to 167 pulled by 200 because the 200 is the one which is deviates, right? So that is the nothing but the outlier. Okay. Next is median. So middle value, right? Whenever you are going to arrange the data in ascending order. So np dot median of heights, it is for that data, it is 160.10. The median is the value that splits the sorted data exactly in half. 50% of values lies below it and 50% lies above it. So for an odd number of values, it is the middle value. For an even number, it is the average of the two middle values. So see this, the middle value is 160. If it is arranged in ascending order. So this median is 160, which is unchanged. So the key properties is it is robust to outliers, but mean is sensitive to outliers. The third one is quantiles. So quantiles generalize the concept of the median. It represents the pth quantile, that is percentage of data falls below this value. So np dot quantile, because we are going to use as a point 25 percentage, 50 percentage, 75 percentage, depends on that value you have to give. It will be giving the exact value, right? So Q1 represents 25th percentile, Q2 represents 50 percentile. So what is 25 percentile? 25 percentile of data values fall below this point. And 50th percentile means this is the median. That median of the data lies below and half above. 75th percentile means 75 data, a percentage of data falls below this point. So it is actually represented by a 5 number summary. So what is that 5 number summary? We can say that actually minimum Q1, Q2, that is median, Q3, then maximum. All those things will be totally, we are providing a 5 number theory here. So that is nothing but the measures of location. And the next is measures of dispersion. So measures of dispersion, what is the question? How spread out is my data around the center? So knowing that center is not enough, the two data sets can share the same mean, but have vastly different variability. So for this, we have standard deviation, interquartile range, and the range. What is standard deviation? Measures the average distance of each data point from the mean. It is calculated by the formula of summation of Si minus h the whole square by divided by n minus 1 the whole square root. And the variance S square is the square of the standard deviation. Okay. So it is actually represented by the syntax np dot std. Std represents standard deviation and np dot var represents the variance. So this low standard deviation means data points cluster tightly around the mean, and high standard deviation means the data points are spread widely from the mean. So since it is also sensitive to outliers. So next is the interquartile range. What is that interquartile range represents? The IQR measures the spread of the middle 50% of the data from the 25th to 75th% and in between 50%, right? So what is that? It is going to calculate. So how wide the central bulk of the distribution? Okay, so that is nothing but interquartile range. It is nothing but Q3 minus Q1. Q3, Q1 we have calculated using this some 75th percentile and 25th percentile. Okay. Next is range. That is nothing but the maximum minus minimum. So simplest measure of spread we can say. So it is actually should be very fragile. One single extreme outlier completely changes the range, because if you have in this previous example you have 200 value, right, that will be very huge compared to the other values, so it will be deviating your answers. So NP dot maximum of height minus NP dot minimum of height will be giving your range. Next is skewness. So what is skewness represents? It's a third standardized one, measures asymmetry of a distribution around its mean. So skewness quantifies the degree and direction of asymmetry in a distribution. It determines which measure of central tendency, that is mean or median, is most appropriate to use. So there are three categories: symmetric, right skewed, that is positive; left skewed, that is negative. So in the symmetric distribution, when skewness is approximately 0, the distribution is symmetric around its center. Both tails are of equal length. It is a bell-shaped curve. So mean equal to median equal to mode in this case. And this is the Python script which is given to Python with the calculate this skewness. So it's stats.skew of heights for the given data set. Already I have explained in the previous example. So 0.08 it is given, right? Next is right skew distribution, G greater than 0, that is positive skew. When skewness is positive, the distribution has a long tail extending towards higher values. Most data values are low, but a few very high values pull the mean upward. So use median to describe center. Mean is misleading here. So mean is greater than median. So long tail to the right, and most values are low, and the values drag mean up. Next is the left skewed distribution. So this is represents whether the skewness should be negative, that is negative skew, G less than 0, when the distribution has a long tail extending towards lower values, that is to the left. Most data values are high, but with a very low values, pull the mean downward. So in this, what are the properties? It should be mean should be less than median, long tail to the left. Then use median here. Also check the data for floor of S, that is value wanted at the minimum value, because it is leftly skewed, right? So commonly known examples we can say is exam scores in easy test, age at determined, product lifetimes near end of life. Most students. So this is the Python code for the given. So it is for heights, one for income and one for exam. This is the same one which is we have described the example with the histogram. Okay. So there are three measures, and incorporating these three measures only we are giving this center quartile range, 5 number summary, minimum, Q1, medium, Q3. So it represents the box plot. So this minimum value, then Q1, that is 25th percentile, then median will be between the Q1 and Q3, and Q3 is near to the maximum value. Okay. So this is the Python code for calculating. So what are the things, how to calculate, and the plot for the box plot, my plot with matplot library. So Q have to calculate Q1, Q3, then QR, lower value, upper value. So outlier is the one which this represented as outlier detection rule. A value is flagged as an outlier if it is below Q1 minus 1.5 into IQR or above Q3 plus 1.5 into IQR. So this 1.5 why we have chosen is for a normal distribution, the 1.5 into IQR rule flags approximately 0.7% of values as outliers. A reasonable balance between sensitivity and specificity for outlier detection. So only we have chosen this 1.5 into IQR rule. So this is called as two keys fences rule. Two keys fences rule introduced by John Tukey. So these are the things which we are discussing aggregating numeric data: location, dispersion, skewness. So this location, mean, median, quantiles, then dispersion, standard deviation, IQ or range, then skewness is presented with three cases: symmetric, right skewed, left skewed. So at last we are going to represent it with a box plot. It is shown in the diagram. So hope you have understand this.